Okay, so here's our lesson 8 for Unit 9. We're going to continue talking about how to solve logarithmic equations. We're going to look at 4 types of problems today. Sometimes you need to use the addition property for logarithms that we learned a little while back to solve equations. The second thing we'll look at is how you can use the subtraction property for logarithms to solve log equations. And we'll also start solving some log equations that involve ln. And then finally, if there's time, we'll see. I don't want to spend too long on this. We may or may not do this last one, depending on how long the lesson takes. We may talk about solving log equations that result in quadratics. Okay, so let's go ahead and start off with our first problem. This is example 1 for the day. Our job is going to be just to be solving for x. The first thing we're going to do with this particular problem is we're going to use the addition property. The addition property for logarithms that we learned a little while back states that we can put these two logarithms together so long as they have the same base number, which they do, by multiplying the arguments. So we can rewrite this problem to look like this. 2x times 6 is 12x. Now once you get to that point, we're going to be solving this in the same way that we solved problems last week. So this was one of our basic type of a log equations that we looked at. And what we do in these cases is we exponentiate both sides. These cancel, leaving me with 12x on the left side. Over here we have 81, and then we just divide. So the first step is all that's really new there. This can be reduced, by the way. I know that 3 goes into both of those. So if I reduce that, I get 27 over 4. So the only step that's new on this problem from last week's stuff is the fact that we're using that property to change it into a single logarithm so we can do all the stuff that we did last week to solve the equation. Okay, so there's that. Got a student practice here for you if you're interested, so go ahead and pause the video, give it a try, see if you can get the correct answer. And there's our solution. I'll let you guys study that for a little bit. Pause the video if you need to study it, and I'm going to move on to our next type of problem, example 2. Example 2, we're going to apply the subtraction property for logarithms. So let's go ahead and see what this does for us. So the subtraction property for logs tells us that I can put these two logarithms together so long as they have the same base. And since it's subtraction, the way we do that is by dividing the first logarithm argument, x plus 3, by the second logarithm's argument, which is x. Okay? After that, we're going to do the same thing we've been doing. You're going to exponentiate both sides. These cancel out. Now this one here, what makes these types of problems a little bit different is how you're going to solve them. Since we have a denominator, the way you deal with that is you're going to multiply both sides by the denominator. So I'm going to multiply this side by x, I'm going to multiply this side by x. Now on the left side, the x's cancel out. And therefore, I'm left with a simpler looking equation now that looks like this. X plus 3 is equal to 81x. And now we have an x on both sides of the equation. So the way that you handle that is you're going to find which x is the smaller x. In this case, it's the 1x. And you're going to do the opposite to bring it to the other side. Since it's the positive x, I'm going to subtract that x. And that will leave me with 3 equals 81 take away 1 is 80, right? Now I've got 80x. And then, of course, we divide. And I do not believe this one reduces. So that's as good as we're going to get for our answer. So there's two things to pay attention to that are kind of different for this problem. The first one is this. Changing the top end of that problem is by using that subtraction property for logs that we talked about. The other one is this step here. Since we have a denominator, we multiply both sides by x. After that, pretty standard algebraic stuff and stuff that we've already done. So give you guys a student practice there. So if you're interested in trying one of these, go ahead and pause the video here and try that one out. And there's our solution. Go ahead and pause the video there if you need to study it. We're going to go ahead and move on to example number 3. I'm going to come back to these ones a little bit later. These are the ones that result in quadratic equations. And like I said, I'm only going to do these ones if we get a little bit of time, if it looks like the video is not running too long. So I'll come back to those at the end if I can. For now, I want to jump into the LN problems. So the LN problems are pretty much going to be made basically a huge repeat of what we learned last week on how to solve these problems. The only thing you have to remember is the exponentiation. When you're doing ln, you have to remember what the base of ln is. It's e. So let's go ahead and get started. So this is an example where we have numbers inside the log, but we also have numbers outside the log. And so we have to get rid of the numbers outside of the log first. The way we're going to do that in this case is by dividing both sides by 8. Now we get to do the new step, okay? We're going to exponentiate both sides, but what's the base? Well, hopefully you guys remember that ln, that's basically just a log with a base of e. So my base is e. So that's what I'm going to be exponentiating both sides with. So to exponentiate, it would look like this. Okay, so that's kind of the new step there. Now e and ln cancel, so I'm left with 7p equals e squared. Now on this side, you could get out a calculator and you could find out what e squared is if you wanted to, but that's not how the answer choices are going to look on your test. They're going to be left as just e squared. So I'm just going to leave them like this as well. But in case you guys forgot, e is actually a number. It's 2.71. So yes, you could turn that into a decimal number and it would look a little bit more normal. But this is how they're going to leave it, like I said, on the test. So I'll leave it like this. So the last thing we need to do here is we just need to divide both sides by 7. There you go. So p is equal to e squared over 7, and that's where we're going to leave it. So weird looking answer, but that's how we're going to leave it. So I'll let you guys do a student practice here. Go ahead and pause the video, go as far as you can with it, and see what you guys get. So on this problem, the first thing you would do is divide both sides by -5. Then you would exponentiate with e. And the last step here, you're going to minus the 1 on both sides to get r by itself. There's your final answer. All right, let's go ahead and move on to another ln example. This is another type of ln problem. But once again, it's just like the ones we learned last week. This is one of the types of problems where you have a log on both sides. And when that happens, what you're going to do is you're just going to cross the log off both sides. And then what you're going to do is you're going to go ahead and solve. So what we could do here is we could minus the smaller n on both sides, right? Now notice there's nothing left now on the right side, so we put 0. And then over here we have 4n minus 1 is 3n minus 7. So now we're just going to add the 7 on both sides and divide. And so we end up with n equals 7/3. Now remember, a little detail that we talked about with the problems that have logs on both sides is you kind of need to make sure that this answer is actually allowed. And you do that by checking the domain. So basically, if we just take this number here and we plug it in, we should not end up with anything less than or equal to 0. Now, if I plug it into this log, it's fine. 7/3 is good. But what happens if I multiply it by 4 and then subtract 7? Well, let's see. So 4 times 7/3 minus 7. That's going to give me 28/3. If you multiply that fraction by 4, think of that as 4 over 1. 4 times 7 is 28. 1 times 3 is 3. We need a common denominator here, so I'm going to put that 7 over 1 and multiply the top and the bottom by 3. You could also be doing this, by the way, on a calculator. It's fine. But anyway, I get 21 over 3. And then 28 take away 21 is 7 over 3. So that's a good answer to get. If you plug in 7/3, you get 7/3, and that's a good answer because it's not 0 and it's not negative, so we're good. So this is in fact our answer. Just remember though that whenever you have a log on both sides, with those type of equations, you need to make sure that you check to see that that answer does not cause the arguments to come out to be 0 or negative. Any of the other log equations we do, you don't really need to do that. There is another one, but we haven't learned it yet. It's the quadratic ones. But so far, of all the log equations we have learned, the ones that have logs on both sides are the only ones you really need to check your answers to make sure that it doesn't make the argument equal 0. All right, here's another one for you guys. I don't like the way this is written because it makes it look like it says ln minus r, and that's not what it says. Because you guys have to understand, ln is not a number. E is a number, but ln is not. ln is more like an operator, operation. It's like addition or subtraction. So we're not subtracting a number from ln. That's not possible. What this means is we're taking the natural log of negative r. Okay, so if it helps, I'm going to write it like this a little bit. So your first step is just like mine, basically. All you're going to do is cross that log off, right? But I'll pause here and let you guys try it. Okay, so our answer would be r equals negative 18. After you cross off your logs, you would have to divide by a negative 1 to get the r by itself. And we have r equals negative 18. Now, is that a good answer? And the answer is yes. If you plug that in up here, right, ln of negative r. And what is r? R is negative 18. So we have double negatives which cancel, and we end up with a positive argument, which is good. You can't have a negative argument, and you can't have a 0 argument, but you can have a positive number argument. So this is a good answer, and we are moving on to another type of ln problem. So this is an example of an ln problem from today. Where we have two ln's on the same side, and we need to combine them together into one log. Since it's subtraction, the way we're going to combine them is by doing the subtraction rule for logs, which says you take the argument of the first log and you divide it by the argument of the second log. Now we're going to exponentiate both sides. These cancel. And what we talked about here was we talked about how you're going to multiply both sides by the denominator. I'll use parentheses this time because it's a binomial. So that leaves me with 6 is equal to e squared x minus 2e squared. So I just distributed this e in the binomial. Okay. Now remember, our goal here is to solve for x. So I want to get x by itself. There's a lot, and what's confusing about this is, once again, you're probably looking at the e, thinking of that as a letter too, and it's in this class, e is not considered to be just a variable letter like x is. It's actually a number. So we're just going to treat it like a number. So the first thing we would do is we would add the 2e squared on both sides. So that cancels there. Now notice these aren't like terms, so to speak. We can't actually combine them in any meaningful way. So we're just going to put them next to each other like this. And the next thing we need to do to get x by itself is we would divide both sides by e squared so that that cancels. And so there's our final answer. 6 plus 2e squared over e squared. Now, just as a interesting little point to consider, I don't know if you guys would ever see this happen, but in this case we're done, just so you guys know. However, let's just say I had like a 4 here. In that case, you would have to reduce those three numbers. You'd have to divide this by 2 to get 3. You would divide that by 2 to get 1, and that by 2 to get 2. Just like you would usually reduce a fraction. But you only do that if all three numbers have something in common that you can divide out. In this case, since in our actual answer here, since there's not a number here in front of the e squared, we won't be reducing it. But just as a fair heads up, you may have to reduce sometimes. So here's one for you guys. Go ahead and give that a try. Pause the video. Okay, so here's our solution. One tricky part here is at the very beginning. Notice this is addition, right? So you would be multiplying the 4 by the x minus 4. And since you're multiplying a number by a binomial, you would be distributing that 4 into both. So if you started wrong, my advice would be to pause the video here, go back and try it again. But this is what you would have gotten if you'd done the distribution part correctly. Next thing we do is we exponentiate both sides. So we end up with 4x minus 16 equals e to the 5th. Adding 16 on both sides gives us 4x equals e to the 5th plus 16. Dividing both sides by 4 gives us our final answer. Okay. All right. So that's the end of the LN problems, and the video went a little bit quick. So I'm going to go ahead and talk about how to solve problems that result in quadratics. So let's go ahead and move on to our final example for the day. So you'll notice that here we need to combine those two logs together. And since it's addition, you're going to combine them by multiplication. So it's going to be log base 3 of. This 4 gets distributed into both of those. So we have 4x squared plus 8 equals 2. Okay. The next thing we're going to do is we're going to exponentiate both sides. Cancel. Okay. The next thing I'm going to do is I'm going to go ahead and minus the 9 on both sides. And there you have it. Now this problem can be solved. This is a quadratic equation, and there's a couple of ways to solve it. Okay. My suggestion would be is if you have one that looks like this, to go ahead and use the quadratic formula. However, just so you guys know, you can use this anytime you have a quadratic. It's just that sometimes it's a little bit of an overkill. Okay. In this case, notice that we have the 4x, we have an ax squared, right? We also have a c, but there's no b. In that case, the way I would suggest solving it is just by getting the x by itself. But if you have a trinomial like this one, my suggestion would be to do the quadratic formula. Or you could factor it if you remember how to factor. Matter of fact, this one factors as well. So another way to solve this is by factoring, but I'm going to use another strategy. Anytime you have just one x there, a good thing to do would be just to get the x by itself. So what do I mean by that? I mean just do basic algebra. Add 1 on both sides, divide by 4 on both sides, and to get rid of the square, we square root on both sides. Now this is where something interesting will happen. First of all, those cancel, so we're left with x. Second of all, when you take a square root, you get a plus and a minus answer. That's an easy thing to forget. And third of all, how do you take the square root of a fraction? Well, you just take the square root of the top and the bottom separately. The square root of 1 is 1, and the square root of 4 is 2. So we end up with two answers here. My two answers are positive 1/2 and negative 1/2. Now, we talked about how sometimes when you get answers, they're not allowed. The only one that we saw so far where an answer is not allowed is when you have a log on both sides of the equation. But when it comes to doing problems that are quadratics, ones that have squares in them, or give you two answers like that, it's possible that those can give you false answers as well. So we need to check those things out. So now I can't plug x into this log, but I can plug x in here. And I need to make sure that both of these answers are okay. Okay, so I'm going to plug in, let's try the half first. So if I were to plug the half in for my x, would I end up with a negative inside the logarithm? Let's see. Well, I don't think we would, right? Because if we square this, you're going to end up with a 1/4. And if you add a fourth to 2, you're not going to get a negative number, and you're also not going to get 0. So this is a good answer. And if we were to plug in the negative half, it doesn't matter, because even though it's negative, when you square it, it still becomes positive. So you end up with the same answer. So both of those are good answers. But just as a fair warning, you do have to make sure both of your answers work when you're doing log equations that involve quadratics, because it's possible that one of them won't work. Here's one for you guys. Go ahead and pause the video and give it a shot. All right, so here's the result. We're adding, so this time you would multiply the 4x squared by the 9 to get 36x squared. Exponentiation gives us 36x squared equals 49. Division gives us this, and then we square root both sides to get positive and negative 7/6. And both of those numbers, when you plug them in, you square them, they're going to become positive. Times 4 is still positive, so we're good to go. All right, so I'll leave you guys to do your homework at this time, and we'll see you next time you do your next lesson for this week.